Hey guys, so I'm going to be going ahead and going over some of these mole conversion problems and kind of breaking down some of these steps. And then at the end, I'm going to do like a multi-step problem so that you guys can kind of see how we go ahead and how we combine some of these steps. And then eventually that'll bring you down into some of the bigger stoichiometry problems in which you have to go from grams of one side to grams of another, or particles of one thing to particles of another, right? So that you're able to solve these problems, okay? So the first one that we're going to do is moles 2 grams, right? So we're going to go 5 moles of CO2, and I need to get my moles of CO2, right, to grams of CO2. So you guys will see that in this, we are going ahead and we're going to follow it that way on the map, right? So we're going to go grams from moles to grams, right? So since I want grams, I'm going to go ahead, I'm going to make sure that I have grams on the top, right? And then I'm going to have 1 mole of CO2. And anytime you have grams, you need to go ahead and you need to use the periodic table. So anytime you guys see grams, that is a huge indication that yes, I'm going to be using the periodic table to figure out how much these things weigh, right? So if you look at your periodic table, you see that carbon weighs 12, each oxygen weighs 16. So since I have 2 of them, I am going to go ahead, I'm going to add those things together. So if I add 12, right, 12 plus 16, you guys should get 44, right? So then I'm going to put 44 grams of CO2. The next thing I'm going to do is double check my units, make sure that they all cancel out. So moles of CO2 cancels out with moles of CO2, right? And then for my math, I am going to go ahead and go 5 times 44, right, divided by 1 grams of CO2. And when I go ahead and when I do that, I should get 44 times 5, which is 220 grams of CO2. Whoa, that came out really sloppy. So that is what you guys would get. So it's going to be the same thing with our moles of H2SO4. So I'm going to go ahead and I started with 7 mole of H2SO4, right? And I'm going to go ahead, I'm going to take that into grams. So I'm going to have my mole at the bottom, and then I'm going to have my grams of H2SO4 at the top. And I know that the grams of H2SO4 go at the top, right, because that is what I'm looking for in my answer, right? So then I have to go ahead and I have to find how much does each of these things weigh. So I would have to go ahead and I would have to reference my periodic table, right? I know that each oxygen weighs 16. Each hydrogen weighs 1, and sulfur I have to double check. So your sulfur, you guys would go ahead and you guys would have to double check your periodic table. So I'm going to go ahead and I'm going to look up sulfur real quick because I do not have my periodic table handy. So if I go ahead and if I look up sulfur, right, you'll see that sulfur has a mass of 32. Perfect. So on sulfur, I would go ahead and I would have my 32 there. So in order to break that down, right, I have 2 plus 32 plus 16 times 4, right, because I have 4 oxygens. So I am going to go ahead and I'm going to add those things up. So 16 times 4, right, so that is going to be 64 plus 34, which is going to be 98 grams of sulfur, right? And since you have that, right, you guys are going to go ahead and you guys will multiply and divide those things. So 7 times 98 grams of H2SO4, right, divided by 1, right, and if you times that by 7, you should get 686 grams of H2SO4, right, so that is what you guys would get. And the next one is going from grams to molecules, so this is the other way. So in this case, we start off with 15 grams of H2O, right? So then I want to go ahead and I want to end up with moles of H2O. So in order to go ahead and to do that, I need to make sure that my moles are on top and my grams are on the bottom, and it's the same thing that I see on here. So if I'm using this map, I want to go from grams to moles, right? So I'm going to go ahead, I'm going to do that. And so you guys will see that the moles are on top and the grams are on bottom. I'm going to go ahead and I'm going to look up how much water weighs. So if I go ahead and if I look that up, right, I have 16 for oxygen, 2 for hydrogen, so I should get 18 grams is 1 mole. And in this case, I have 15 times 1, right, divided by 18 will give me my moles of H2O, right? And you guys will see if you guys go 15 divided by 18, right, you get 833, right? And that is what you guys should get on there. Right, the next thing that you will see is that we have 10 grams of HBr, right? So then you guys are going to set up the exact same way, right? So first thing that I am going to do is that I have to go ahead and I have to make sure that my moles of Br is on the top, and then my grams of HBr is on the bottom. Then I would go ahead and I would look up on my periodic table, how much does bromine weigh? And if I go ahead and if I look that up, you'll see that my bromine weighs 80 plus 1 should be around 81 grams. And then the same deal on here, I have 10 times 1 divided by 81. And then I should get my moles of HBr. Then I'm going to go ahead and I'm going to divide those. So I would have 10 divided by 81, right? And that would be equal to 0.12 grams of HBr, right? So that is what I should get on there, right? And then you guys are going to have the same deal for your moles to particles. So their moles to particles are your same thing, right? It depends on which way we're going, except we're going to go ahead and we're going to use our Avogadro's number in order to go ahead and to go from moles to particles. So I start off with 0.2 moles of O2, and I'm going to go ahead and to go to particles. So I'm going to have moles at the bottom so that moles cancel. And then in this one, I'm going to have particles. So you'll see that my conversion factor is actually 6.02 times 10 to the 23rd, right? So then I'm going to go ahead and I'm going to multiply those things out. So if you guys go ahead and if this is easier to do on Desmos, sometimes if you guys do it on a different like calculator, you guys will see that you're more likely to like mess up. So I'm going to go ahead, I'm going to plug this in on my Desmos. So I'm going to go 6.02 times 10 to the 23rd. And I'm going to go ahead and I'm going to take that answer times 0.02. Oh no, 0.2, my bad. 0.2. And then I should get, so this will be 0.2 times 6.02 times 10 to the 23rd. And I'm going to divide that by 1. And you guys should see that I get 1.204 times 10 to the 23rd particles. Right, and then I'm going to do the same thing for this NaCl. So I have 0.8 mole of NaCl, right? And then I'm going to go ahead and I'm going to make sure that I have everything on here. So I should have 1 mole of NaCl. And then I'm going to go ahead and I'm going to have particles on top because that is what I'm converting to. And I am going to multiply those things in a sec. So I should have 0.8 times 6.02 times 10 to the 23rd, right? And then I should divide that thing by 1, and I should get 4.8 816 times 10 to the 23rd particles. Right, so that is what you guys should get on there. Right, and then sometimes they'll ask you to go ahead and to go the other way. So this time we're going to go ahead and we're going to go from particles to moles. Right, so we have 7.0 times 10 to the 26, right, of particles. Particles, right, and then I am going to go to moles. So in this case, I want moles at the top, and then I want 6.02 times 10 to the 23rd at the bottom. So in this case, I'm going to go ahead and I'm going to be dividing, right? So I'm going to go ahead and I'm going to do 7.0 times 10 to the 26th times 1 over 6.02 times 10 to the 23rd, right? Punch those into our Desmos that I'm going ahead and that I'm getting done to the 10 to the 26, my bad, times 10 to the 26th, right? And then I'm going to go ahead, I'm going to take my 6.02, oh shoot, times 10 to the 23rd, and then I'm going to go ahead, oops, gonna divide that. I'm sorry guys, I'm having a little bit trouble of going ahead and dividing the two things. So I'll take the answer, divide. Then you guys go ahead and you divide those two things, and I'm sorry, I'm not punching these things in right. I messed up. 6.0 times 10 to the 23rd, and you should get something around 1162.7 moles, right, of O3. So that is what you guys would get. And you guys are going to do the same thing on here. So you have 1.10 times 10 to the 20th particles. Then you guys would go ahead and you guys are going to have your mole at the top because that is what you're solving for. And then you have 6.02 times 10 to the 23rd at the bottom. Then you guys are going to go ahead and you guys are going to take those things and you're going to divide them. So 1.0 times 10 to the 20th divided by 6.02 times 10 to the 23rd. So then I'm going to go 1.0 times 10 to the 23rd. Oh, 20th, my bad. 20th. I knew that answer looked funky. And then you should get 1.66 times 10 to the negative 4th moles of H2O2. So that is how you guys would solve those problems. Okay, last but not least is going to be our liters to moles problem. Again, this is not super common, but I want to make sure that you guys understand how to go ahead and how to solve these things. So then I have 5 liters of CO, and I'm going to go ahead and I'm going to make sure that my moles is on top, and 1 mole is 22.4 liters. So super simple on here. I would go ahead and I would go 5 divided by 22.4, and again I know those things because I would multiply across and then divide across the bottom, and you guys should get 0.22 moles of CO. Right, same thing on here. I have 2 liters of N2. I have to convert that to a mole, so I'm going to use the same conversion factor. And then I would have 2 divided by 22.4. And then this should give me 2 times 1 divided by 22.4 liters. I forgot to write my liters on there. That would be 0.08. Wow, that's sloppy. 0.089, right? And this will be mole of N2, right? And you guys can do the same thing the other way. So if I went ahead and if I had 8 moles of CH4, I am going to go ahead and I'm going to convert that to liters. My bad, I wrote the problem wrong. We're going to liters, right? So if I want to have liters, right, I want to make sure that I have my 22.4 liters at the top is 1 mole. And again, I want the moles to make sure that we're canceling. So that's why I'm going ahead and that's why I'm formatting it that way, right? And in this case, I'm going to go 8 times 22.4. Right, and then this should be 1747.2 liters of CH4, right? And then same deal on there, so I have 7 moles of SO2, and then I want liters at the top, and I want to have moles at the bottom, so then I would do the same thing. I'm going to go 7 times 22.4. Right? And then I have 156.8, right, liters of SO2, right? So that is what you guys are going to do. And hold up, I'm going to check my other answer. Oh, shoot. Yeah, this answer is really off. I was like looking at it and I was like, something's wrong. Okay, so this one is 179.2 liters of that. Okay, so a couple of things that I want to point out before I let you guys go on this. Number one, this, when we have the grams, you guys will notice that this is the only time that I'm going ahead and I'm taking into account how much each of those things weigh. So that's the only time that I'm going ahead and really looking into that. The rest of them, I just use the straight conversion factor. So for example, for particles, you guys will see that I'm using that Avogadro's number, the 6.02 times 10 to the 23rd, because that's how many particles there are, right? Depending on the problem, I would go ahead and I would flip them, right? And again, if you're not sure, look at this chart here. Am I going from particles to moles or am I going from moles to particles, right? And then looking at that chart, I can really see how those things are going ahead and how those things are working out, okay? Then your next thing is going to be your moles to liters. It's the same deal. We're not doing any math on how much any of those elements weigh, right? All I'm looking at and all I'm using is this 22.4 liters and using that as my guide. And then on here, right, you'll see depending on which direction I'm going, makes us depend on what we are going ahead and what we are going to use. If we're going to have moles at the top, if we're going to have liters at the bottom, right? And remember that the thing that you guys want, right, whether it's liters or moles or particles or grams, right, that is going to be the thing that you guys want on the top. And you multiply across, divide by the top and the bottom, and then other than that, you guys should be good. Okay, thank you guys, and good luck on your